Right, good morning. This is then the trigonometry questions of November 2018, question 5, 6, and 7. We're going to start with question 5. It says in the diagram, the point K1, there is a point in the second quadrant and root 5 units from the origin, that radius length. Now, if they give me those coordinates, I can substitute in there. My x value is k and my y value is 1 into my triangle, so I can work with a triangle like that. And R is a point on the positive x-axis and obtuse angle ROP, that angle is theta. I want to obviously first start by actually calculating the value of k. Be careful, it's on the negative x-axis, so whatever answer you should have there, you get there should be negative. So I'm going to use Pythagoras there. K squared is equal to root 5 squared minus 1 squared. Root 5 squared is 5, 1 squared 1, so this is 4, and that means that k is going to be, please be careful, it should be negative 2. Alright, 5.1.2, I have a ABC. Without using a calculator, calculate the value of tan theta. So tan theta, opposite, which is 1 over hypotenuse, which is negative 2. So 1 over negative 2, or negative a half. Cos 180 plus theta. 180 plus theta typically lies in quadrant 3, where cos is negative. Reduction. So negative cos theta, and then negative cos theta is adjacent over hypotenuse. So negative 2 over root 5, negative 2 over root 5. The negatives will cancel, giving me positive 2 over root 5, and please just rationalize the denominator. What I mean by that is you don't want a square root in the denominator. So if there is, you just multiply with the square root over itself, so that you have 2 root 5 over 5. Then question C, sine theta plus 60 in the form, sine theta plus 60 in the form a plus b over root 20. So they give me a place where I can stop, where I don't rationalize the denominator. So sine theta plus 60, I'll see when I get to the answer when to stop there, because I know they gave me something. I'm going to expand using the formula sine theta cos 60 plus cos theta sine 60. I'm going to use my special angles there, and the thetas I'm going to read from my triangle there. So sine theta is going to be 1 over root 5. Sine theta 1 over root 5. Cos 60 special angles is 1 over 2. Whatever method you use, cos theta is going to be, that's most now negative 2 over root 5. Negative 2 over root 5, and sine 60 is root 3 over 2. Okay, right, and then I'm just going to simplify this. So 1 times 1 is 1, 2 times root 5 is 2 root 5, plus, actually minus 2 times root 3 is 2 root 3 over 2 times root 5. And then since this is a common denominator, I can write this as 2 root 5, 1 minus 2 root 3. Now they say I must leave that as a plus b over root 20. To get this to root 20, you can put the 2, you can rewrite 2 as root 4 times root 5, and that is then 1 minus 2 root 3 for root 5 and root 4 multiplied is going to be root 20. So that's how they want it. Alright, and it's, well, technically speaking, if you want to also a plus b, if you want to also write it like that, to be very, very strict on yourself. But I suppose the 1 minus 2 root 3 is fine as well. 5.1.3 says use a calculator to calculate the value of tan 2 theta minus 40. It's not very often that they say do use a calculator. Correct to 1 decimal place. Okay, now tan 2 theta minus 40. I do not have a formula for tan with compound angles, and I also do not have a formula for tan 2 theta. So I'm going to firstly just make this sine 2 theta minus 40 over cos 2 theta minus 40 sine over cos, and then I'm going to expand that, so I have sine 2 theta cos 40 minus cos 2 theta sine 40 over cos 2 theta cos 40 plus sine 2 theta sine 40. So I just use my compound angle formulas, and then also I want to use the double angle formulas there because I don't. Oh, you got so excited when I said now we use your calculator, and you thought, oh, it's going to be easy. And now you still have to do a lot of work before you can actually use your calculator. So I'm going to replace sine 2 theta with 2 sine theta cos 40 minus cos 2 theta. You can replace with either one of the three formulas. So I'm going to use cos squared theta minus sine squared theta sine 40 all over, and yet again you can use either one. I'm going to again use cos squared theta minus sine squared theta cos 40 plus, and then that's, I'm going to make 2 sine theta cos theta sine 40, and this is ridiculously long. Okay, now I can use the diagram to just substitute values for the theta things. So sine theta from the graph, sine theta is 1 over root 5 and cos theta is negative 2 over root 5. So I'm going to everywhere substitute that. Sine theta is 1 over root 5, cos theta is negative 2 over root 5, cos 40 minus cos squared is then going to be negative 2 over root 5, which is going to be 4 over 5, minus sine squared is 1 over root 5 squared. It's going to be 1 over 5 sine 40. It's just easier to type in the calculator if I somewhere already squared that with my head quickly. And same thing there, cos squared minus sine squared is going to be 4 over 5 minus 1 over 5 cos 40 plus 2 sine theta is 1 over root 5. Cos theta is negative 2 over root 5 and sine 40. Yo. Okay, and then I can type this into my calculator. It's insane. Okay, so I need a fraction. I'm going to type 2, 1 over root 5. Nope. Negative 2 over root 5. Negative 2 over root 5. Cos 40. I'm quickly going to type this. 4 over 5 minus 1 over 5 just to spare me some time. Ugh, I did something crazy there. Minus is 3 over 5, so just to spare me some time as well, sine 40. And then I can't believe that. I'm now trying to be quick, and now I'm just making myself slower. You can just type this into your calculator yourself, I suppose, and calculate that. The reason why I'm now doing this on camera is also if you don't get exactly the same answer as me at the end, then you can at least go and check how did you type this different than I did, because sometimes when we use our calculators we still get wrong answers. So that's 3/5 times cos 40. So at least you can also sort that out. 1/√5 negative 2/√5. Why does it not want to take the root button now? I suppose. Oh, I changed something in my settings now. But okay, yeah, I'm just gonna continue without you type that into your calculator. I'm now struggling to do that, and I feel like I may be wasting your time. Okay. All right. Okay, so let's continue to 5.2. And I pressed something on my calculator to make it weird. And I can clear the screen. I did clear the memory to fix it, but then I have to now retype it again from scratch, and it's just so long, and I think most of you will be fine getting that answer there if you can work your calculator better than I do. Okay, prove the following identity 5.2. Right, so I have, there's my identity, left hand side is equal to 2 tan 2x. I'm going to write the left hand side here, and I want to get to 2 tan 2x 5.2. Okay, so my left hand side is cos x plus sine x over cos x minus sine x minus cos x minus sine x over cos x plus sine x is equal to. Okay, so typically when I have fractions in mathematics, I want to put them on the same common denominator. So my common denominator is going to be cos x minus sine x times, let me just put brackets around that, times that. That's going to be cos x minus sine x times cos x plus sine x, cos x plus sine x. And from this fraction to get there, I have cos x minus sine x that I multiplied with that at the bottom. So I want to also multiply the top, which is that. So I'm going to just square that. So the top is going to be cos x plus sine x times cos x plus sine x minus. Then from there at the bottom, from there to there, I multiplied with this bracket. So at the top, I'm also going to multiply with this bracket. The top, which is cos x minus sine x, cos x minus sine x, I'm going to multiply with that bracket also cos x minus sine x. And now I've got a lot of FOIL products to do, which I think most of you in grade 12 were so perfectly fine with. I'm just quickly going to do them here without really bothering too much about explaining. I think most of you are fine with that. Plus sine squared x. And then there, you can either just keep it in brackets first, and just multiply out the FOIL product and then multiply in the negative. Or as you multiply this, just remember to change all of the signs. So I have cos squared x, then minus sine cos is minus 2, but with that minus, it's going to be plus 2 sine x cos x. And then plus sine squared, but minus sine squared due to the negative in front. Okay, and then this is going to be cos squared x minus 2 sine x cos x. No, that actually falls away. Plus and minus, it's different ones. It's not a square. So plus sine x minus sine x, and then minus sine squared minus sine squared x. Okay, so I have, let's look, there's cos squared minus cos squared, which will cancel or fall away. Sine squared minus sine squared, which will fall away. And then I have 2 sine x cos x plus 2 sine x cos x, which is then 4 sine x cos x over cos squared x minus sine squared x, which cos squared minus sine squared is the formula for cos 2x. And this looks a little bit like the formula for sine 2x, but that should be a 2, which you can divide by 2 or multiply by a half over a half, or you can just break that 4 into 2 times 2. So that I have the 2 sine x cos x, which is ideal for the formula that I want. That's the formula for sine 2x. So I have the 2 there, sine 2x over cos 2x, and sine over cos is tan, with the 2 in front is then 2 tan 2x, and that's what I want to come to on the right hand side actually. Okay, so there is that identity. And then question 5.3 says evaluate without using a calculator. Here is a bit of arithmetic number pattern chapter stuff. I hope you remember this. The sum from where a is 38 to where a is 52 of cos squared a, right? Okay, so without a calculator. All right. Let me quickly think. I think that the easiest thing is expand this a little bit, right? So this is basically cos squared 38 plus cos squared 39 plus cos squared 40 up until plus cos squared 41 up until plus cos squared 52. Basically, if I expand this is what sum means. I take the sum starting from 38 to 52, and I want to add that. Wow, level 4 problem solving question at its best. Okay, now you 52 and 38 makes 6090. And 39 and 51 makes 90. So if you group them together like this is cos squared 38 plus cos squared 52, the first one and the last one, right? Plus 39 and 51, cos squared 39 plus cos squared 51. So I group the second term and the second last term, plus cos squared 40 and 50, 40 and cos squared 50. If you group them together like that, do you notice that this gives 90, this gives 90, this gives 90, and if you change with 90 minus, let's use the first one, so this is going to become sine squared 52, 90 minus 38, change sine to cos, plus cos squared 52, plus then I change this also to sine squared 51 plus cos squared 51, etc. Then this is going to become 1 plus 1 plus 1. And I just need to know how many pairs are there, basically. So there's 38 and 52, 39 and 50. Let's just quickly, every one of them will make 1, right? So 38, 52, 39, 51, 40, 50, then 41, 49, 42, 48. I just want to count how many there is. 43, 47, 42, 46, 41. This is 8, 9, 40, 41, 42, 43, 44, whoops, 45. And this 1, 9, 8, 7, 6. 44, 46, and 45. Okay, which sine squared 45 plus cos squared 45 is also going to be 1. So this is 1, 2, 3, 4, 5, 6, 7, 8. So my answer is going to be 8. Okay, problem solving question. Very cool question. Whenever you see problem solving questions, my suggestion is just continue, leave space open to work with it, continue with the rest of the paper, mark them and come back at the end when you have time to sit and play and think of what you're going to do with it. All right, very cool question, this one though. And I would like to know if there's anybody that comes up with a different way of answering this actually. You can just answer in the comments below or post a pic of your solution if you did something else there. But very cool question. Let's look at question 6. Okay, question 6. Sorry. Okay, I don't have corona at the moment. I just have a bit of a clogged voice. Yeah, I'm not sick though. Okay, consider fx minus 2 tan 3 over 2x. Okay. Right. Oh, this is a graph question without an actual graph there. There's my graph. Minus 2 tan 3 over 2x. Write down the period. Okay. This value there affects the period. The normal period of a tan graph, unchanged, is 180 degrees. So if I change this with a factor 3 over 2, I'm always going to divide with that. Sure. 180 divided by 3 over 2 is 120. So then my new period is going to be 120. 6.1, the period is going to be 120. Yeah. So that stretches or shrinks, but it works the wrong way around. So it's not going to be 1.5 times bigger. It's going to be 1.5 times smaller. That's why I divide the old period with 1.5. Okay, then the point A, T2 lies on the graph. Determine the general solution of T. So that's my Y value. I want to know where minus 2 tan 3 over 2x is equal to y is 2. And then just solve this basically general solution. So 2 divided by negative 2 is negative 1. I get my reference angle. As I've said in a few videos before, your reference angle, even if that is 1, you're going to use positive shift tan positive 1 to get your reference angle of 45. and then I place this angle 45 in the quadrants where tan is negative. So you can either just place it in quadrant 2, the quadrants are 2 and 4, you can either just place for tan, I can either just place that 45 in quadrant 2 plus k 180, or sorry, or you can put that 45 in quadrant 2. This is not correct. 45 in quadrant 2 is 180 minus, which is 135. 135 plus k 180, or you can put this reference angle in quadrant 2 and 4 and then still put plus k 360, as you do with sine and cos as well. You have the two options, they mean the same thing. Okay, and then the one thing that's important, even if that's negative, you work out your reference angle with a positive ratio, place it in the quadrants. The second thing that's important, if you have a complex angle here, please don't solve it. First put it in the quadrants and then you're going to solve. So I'm going to divide by 3 over 2. Divide by 3 over 2. 3 over 2 is 19. And divide the 180 as well by 3 over 2, which is 120, as I already said there. And this also confirms for me that the period of this graph is 120, because I have a value that occurs every 120 degrees, meaning the graph completes in 120 degrees, which is also good to know. Okay, so there is my answer of 6.2. 6.3 says, on the grid provided, draw the graph of f. Clearly show all asymptotes, intercepts with the axis and endpoints of the graph. And I showed this in a previous video as well. I'm quickly going to show this again from I'm not going to draw the graph, but I'm going to quickly just show you how to get the points on your calculator, which I think for most of us is the easiest way to draw a graph. Something as complex as this, where I have to stretch the period by 3 over 2, and I have to reflect it, and I have to stretch it like that. It's just too many things to consider in thinking where this graph should lie. So I think it's easier to just work with a table. I press that mode button, then I'm going to go to table, and then I'm going to enter here my equation minus 2 tan 3 over 2 x, and your x you're going to have with that button, and there is my equation equal. It asks me for another equation, not necessary, and I want to start at minus 120, and I want to end at 180. And for trigonometry, a good step is always sum 30 degrees. And there is my points that I can plot. So at negative 120 on the graph, I'm just going to start off, but I'm not going to do the entire thing. I'm going to now mark my graph minus 120 in steps of 30 degrees, because that's what I entered on my calculator. Minus 90, minus 60, minus 30, 0, 30, up until 180. And then at minus 120, I have 0. So I'm going to plot that. At minus 90, I have negative 2. There's negative 1. I must just show that on the sketch. Negative 2, 1, 2. So at minus 90, I have negative 2. At minus 60, I have an error, which means that's an asymptote. Then at minus 30, if I go down, I have 2. At 0, I have 0. At 30, I have minus 2. You get the picture. And then I can see there is my tan graph, and I can just continue like that to sketch. All right, so that's 6.3. 6.4. Use the graph to determine for which values of x will fx be bigger or equal to 2 in this section. So for this, there it's bigger than 2 between minus 60 and 30. At 30 it's equal to 2. So between minus 60 and 30, 30 included because I want bigger or equal to 2. At 30 it is 2. So I include that. I can't include 60 because there's an asymptote, right? And then the next section is going to be there, I think, from 60. If I look at this pattern that I see here, it's going to be from 60 to 90. It will have a point there. So if I look at what's happening, so if you finished the graph, you will be able to see it clearly, but I think it's going to be from 60 to 90, and also at 90 it's going to go through to 60 is a asymptote, 90 it's a 2. You see again at 90 it's a 2, so 90 included, and then well, there's 180 is my last. Okay, so there, the rest of the graph is not above 2. So for this question and 6.5, describe the transformation f has to undergo to form the graph of gx, which is negative 2 tan 3 over 2x plus 60. So they give me this graph and they say, what is the transformation that f has to undergo? Now, f is minus 2 tan 3 over 2x. So minus 2 tan 3 over 2, this is f. What's happened is that's plus 60. And the p-value typically moves the graph left and right. If it's a plus, it's going to move to the left. If it's a minus, it's going to move to the right. So this is move or translate 60 degrees to the left. All right, that's question 6. Question 7, last question for this video. My sine, cos, and area rule 2D, 3D type problems. A pilot, okay, is flying a helicopter. There he is at point A, which is h meters directly above point D, that height h. On the ground, he notices a strange object at point B. So there is something weird going on there. The pilot determines the angle of depression from A to B is 30 degrees. So from where he is, if he looks at that, if he looks forward to there, from that line down to that B is 30 degrees. He also determines that the control room at point C is 3h meters from A. So he's h meters in the air, and he's double that length, 3 times that length, sorry, from the control room. And angle BAC is 2x. So there's an angle there. 2x. Points B, C, D are on the same horizontal plane. That's the ground. The scenario is shown in the diagram below. Determine the distance AB in terms of h. So that distance AB, you can see if that's a horizontal line and there's the ground, that this is also going to be 30 degrees. Yes, it's alternate angles. Those lines are parallel. It's both horizontal line, so that's 30 degrees. I want to calculate AB in terms of h. So this is a 90-degree triangle. I can just use sine opposite over hypotenuse. Okay, so 7.1 7.1 sine 30 is AD, the height, over AB, and I want to have AB, so I'm going to multiply that on the other side. AB sine 30 is equal to h, so AB is h over sine 30, and sine 30 special angles is 1 over 2, so this is h divided by 1 over 2, or h times 2 over 1, so 2h. Alright, so AB is 2h. Okay, I have that there is 2h, that is 3h. Show that the distance between the strange object and the control room, that is BC, is given by this. So I have that side, I have that side, I have that angle. If I have three sides, I want to work out this side, so it's part of my sides. If I have three sides and an angle, I work with cos rule. If I have two sides and two angles, I work with sine rule, but I don't have that angle. I don't have that angle. I have that one, but not this one, right? So three sides and an angle, I'm going to work with cos rule. The cos rule is, it's on your formula sheet, by the way. A squared is b squared plus c squared minus 2bc cos a. I'm going to work with that a, the one that is actually shown as a in my cos rule as well. So that, then the one across from it, bc, must be the side that comes alone in here. So I have bc squared is equal to, and the b and the c is 2h and 3h. Doesn't matter which one you use as b and which one you use as c, will give you the same answer. So I'm going to use b as 2h and c as 3h. And my a angle is 2x, so cos 2x, and this is now bc squared is 4h squared plus 9h squared minus 2 times 2 times 3 is 12. H is h squared cos 2x. So this is 4 plus 9 is 13h squared minus 12h squared cos 2x. And I'm going to take out 12h squared as a common factor here. So there's 13 and there's 12. So I can take out 12h squared as a common factor, leaving me 1 there. I took out that minus cos 2x. Okay. And let's just make this cos 2x something with a cos squared, the one with only cos in, 2 cos squared minus 1, because where I'm going here, I need a cos in the equation or the sine. So the cos 2x has 3 formulas. 2 of them has sine in. The other one has 2 cos squared x minus 1. Okay, I think I'm going to just multiply this. Oh, I did something very wrong here. Oh, when I take out the 12h squared, I can't take out 12h squared. Ooh, I'm doing crazy things. Okay, let's just go back there. Sorry about that. Wow, 13h squared minus 12h squared cos 2x. Hopefully some of you noticed that I can't take out 12h squared because 12 and 13 is not a common factor, 12. Sorry, I can take out the h squared, but that's as far as I can go. Let's just leave it like that quickly. Wow, that's such a basic math mistake to make. So cos 2x, I'm going to make 2 cos squared x minus 1. That's embarrassing, but okay. Okay, so I have 13h squared minus 12 times 2 is 24 h squared cos squared x, and 12h negative negative positive 12h squared times 1 is 12h squared. So I have 13 and 12. This is like terms which I can add. 25h squared minus 24h squared cos squared x, and I can take out the h squared as a common factor, but not the 25 or 24, because they are not like they don't have a common factor actually, the numbers. So I have h squared 25 minus 24 cos squared x, like that. Good. And this is bc squared. So bc is going to be the root of h squared is h, and the root of this thing can't work it out, don't work out the 25 because there's a minus in between. I'm just going to put the root over 25 minus 24 cos squared x. I apologize for my brain also being on holiday. Alright, and that is where I want to come h25 minus 2 cos squared root of 25 minus 24 cos squared x. And that is where I want to end up. Right, that is then the trigonometry for November 2018 paper. I hope this have helped you a lot. Also, just check on the channel. There are videos for the trigonometry from 2015, 16, 17, and then this is the last one, 2018. And I hope this is